All right, so looking at this first row, can we integrate? So overall, what are you thinking we could let u equal on these problems? Natural log of x. So that should probably work on every problem. You see how we don't want to let u equal the whole denominator here on a? If we did that, then there wouldn't be anything left for du. Okay, so if u equals just natural log of x, then du would be 1 over x dx. So what we're looking for here is that we have a u, and the other part of the problem is the du. So like a works. What else works? Which other one, if we let, like on b, if we let natural log of x equal u, is the other part of the problem covered by du? Yes. So a and b both work. The difference between these two is that here you would have 1 over u, and here you would just have u. Okay, I'm not going to finish any of these problems. We're just kind of setting up and thinking about strategies. Okay, what's wrong with c?
There would be nothing left. So
Yeah, I don't have a matchup. I don't have that 1 over x anywhere. And remember, you're not going to let u equal just x, and you're not going to let u equal the whole thing. And we don't know what the integral of natural log of x is. We know what the derivative is, but not the integral. So we can't do that one. So that's kind of what we're going to do each time. So looking at the next row, what are your thoughts here? How could these possibly integrate? So let's try Arcsin first. One of these works with Arcsin, and then the other ones don't. Does anybody have an idea which one? The first one? So if we let a equal 1, u would equal, this is the only time we're going to let u equal x, but that's because we have a formula. All right? Not because we're doing like normal u substitution. So a equals 1, u equals x, du equals dx. So this whole thing's taken care of. This whole thing's taken care of. So this would be the Arcsin problem. And we're going to practice some more of this inverse trig later. But right now we're just kind of identifying what type of problem. These are not going to be Arcsin. See how there's an x in the problem? On b it's in the numerator, on c it's in the denominator. So how could we do these?
Well, didn't we do it like that yesterday? We split it out.
So we can't split it up unless like the numerator was something plus something. Then we could split it up. And we can't do long division. You didn't say this, but I'm just bringing it up because of the square root. So let's go back to basics. Like how would we have thought about these problems weeks ago? What would we have let u equal on these?
The denominator.
So even before that.
X.
So what was our very first thing with u substitution? Use parentheses, right? Isn't this radical symbol just another way of saying parentheses 1/2? So what are we going to let u equal? 1 minus x squared. Letting u equal the denominator would not be a bad try. It wouldn't work, and I may comment on that. But let me show you what happens when you let u equal this. Then du, what would that equal? Negative 2x dx. The negative 2, that gets divided over to the other side. Okay, and we're not going to finish this problem, but we know we can deal with that. So my question is, which one of these two, if we let u equal this 1 minus x squared, which of these two has an x dx in them? One of them is an obvious yes. One of them's a no or a maybe. You might be thinking maybe, but which one looks like this works with? You guys understand what I'm doing here, or do I need to explain this differently?
Are you asking between B and C?
I'm saying between B and C, which one is looking like it's working?
B.
B, right? This is your du. So that's how we would work that problem. There is an x in C, but it's in the wrong place. It's in the denominator. Okay, that's like a 1 over x. Okay, so we can't integrate C. So on some of these, it's because we don't know how to yet. because we haven't integrated everything there is. We've integrated everything we're going to do this year, but some things we just don't know how to do yet. Some things are impossible to do. All right. I'll go ahead and say this. I am not going to give you problems on a test that you can't do. Okay. Everything I give you on a test and the AP test will be things you can integrate. Here's the difference, or here's why. Whoops. I don't know what I'm doing right here. Oh well, I'll just leave that there. Here's why we're doing this, so that we can kind of identify when we're getting stuck and when we're using the wrong strategy. So looking at this next row, what are your thoughts?
X minus 1.
What is x minus 1?
U.
U. So this would be how we start this problem. Starting the problem is generally the hardest part. So then du would equal dx. So which of these three looks like it's working out the easiest? Like, which one could, if I said you're going to have a test question and you can work problem A, problem B, or problem C, which one would you work out?
A, for sure.
A, because here we have a U, and then everything else, it matches up perfectly. We can do A. And I know we're not finishing any of these problems. We're just starting them. That's the hardest part. So if you look at B and C, does that mean they're impossible? Say that again. We have to do a Toco. Both of these are going to be done through Toco. So how do you know when to use Toco? I'm not going to tell you on the test when you have a Toco problem. All right? So remember, Toco stands for that other kind of. It's when you have an extra x. So see how this x is extra here and here? All I got to do is figure out what x equals and plug it in. So what does x equal? If you eat u plus 1. Now we're going to practice some Tocos, or at least one later. But right now we're just saying that's how you know. All right? All right, what about the next few? What are your thoughts? What could we do here? And especially, let's just look at A and B together because they're more similar than C.
Do e to the square S.
Yeah, let's let U equal, and in both cases, that's x squared. Because there was a power on E, and it was more complicated than just an x, so I'm going to do a U substitution. Then du would equal 2x dx. The 2 again, easy to deal with. So here's my question. Instead of me asking you which one is working, would you rather be working A or B?
B.
Why B? It has an x and a dx. You want those two things to match. Because what would happen here on B is you're left with e to the u du, which we can integrate. On A, I can't do that problem. There should be an x there, and there's not, so I don't know how to work that. So let's use that same strategy here to see if C will work out. What we're hoping for is that if we let U be the power on E, that the du will be everything else in the problem. That's what we're wanting to have happen. That's how we know if we're on the right track. So what is U?
X to the negative 1.
Yeah, 1 over x, which is the same as x to the negative 1. I'm going to write it as x to the negative 1 because that's easier to do the du. So that's going to be negative 1x, subtract 1 from the power. The negative 1, very easy to deal with. It just goes out in front of the integral symbol. And so my question here is this right here, x to the negative 2 dx, is that taken care of in the problem?
Yes.
Yes. X to the negative 2 is the exact same thing as 1 over x squared. Okay, if the 1 over x squared had not been there, we couldn't do this problem. It has to be there. So you're not going to write it down here. You're just going to write e to the u. On the last quiz, this was the most common mistake. People are halfway doing u substitution. They know it should work out, but they're not clear on that everything swaps out for something else. All right, what about this last group? Any thoughts here?
Arcsin, tan.
Arctan? Okay, so let's try Arctan first. I'm not gonna tell you which one it is. Anybody think they know which one is Arctan? A, B, or C? I'm hearing some A's and some B's. Let's try it. So if we think this is an Arctan problem, by the way, this would be du. I'm not really writing this in the best order here. It'd be a squared plus u squared. That's what we're looking for. So what would a, they all have the same denominator. So what would a equal? 1. U would equal x squared. See how this is u squared and this is x to the 4th? So then what would du equal? 2x dx. Again, the 2 I can divide over and there's no problem there. But if I'm going to do arctan, then there better be an x dx in the problem. So which one is that? B. So good job if you said B. You were correct. So we're not fully working out that problem, but you would work it out using the arctan formula.
Once you kind of grasp the knowledge, can you just, as long as you see that it all works, can you just go straight into the formula?
If you get the right answer, you're in good shape. So yes,
Okay.
there are going to be times when you can skip little steps, but I would say if it's causing you to make mistakes, then don't do that.
Yeah.
So A and C, any other ideas how those might possibly be integrated? What's another thing we did before we learned about arctan? Cry? What did we let u equal?
The denominator.
The denominator. So let's do that. If u equals the denominator, one of these is going to work and one's not going to work. And by work, I mean the du is going to be in the problem or not in the problem. So what is the derivative of 1 plus x to the 4th? 4x cubed. Okay, the 4 is not the problem. But there better be an x cubed dx in order for this to work. So which one does that happen with? C. That means A, although it looked pretty good at the beginning, we can't do that one. Okay, you are not going to get problems that can't be done. So when you get stuck, you don't get to just cross it off. You got to try a strategy and try another strategy. So what we're going to do next, this will probably take most of the rest of the class, is we're going to go over every strategy we know. I'm not going to go over them in the order that we learned them. Now that we know all of them, they kind of have naturally grouped into certain things. This is the order in which I would try a problem. Just given some problem at random, this is what I would try. I would first see, can I do this without even using u substitution? Because if you look at number 1 and you're like, oh, I know what to do, let u be the thing in parentheses, you're going to get stuck and you're going to get it wrong and it's going to take time. When this is actually a pretty easy problem. I get that there's parentheses there, but do you know how to integrate 2x? What's the antiderivative? X squared. We go 2 over something, we add 1 to the power, and then that goes down there. So x squared. What about the next piece? 1 6 x to the 6 plus c. Y'all are doing really well, by the way, with plus c's. So try this first. I'm going to put the section numbers up here, so if you need to, you can go back and review that in your notes. So that was all the way back to 4.1. Okay, my pen stopped working. There we go. All right, so then also very early on, we started doing basic trig. This is just, do you know your 6 trig derivatives? In other words, whose derivative is cosine x? Sine x. That's all you have to do on this problem. Don't overcomplicate it and try to make it into u substitution. whose derivative is cosecant squared x?
Negative cotangent.
Okay, so the derivative of cotangent x is negative cosecant squared. So I need to put a negative there. The derivative of cotangent is negative cosecant squared, because the derivative of any is negative. So if the derivative of cotangent x is negative cosecant squared, then I got to put a negative in to account for that. Because if I don't put this negative here, then what I should have had in the beginning is a negative. Here's another way, and a plus c. Here's something else that somehow this makes more sense to students. Put a negative here and put a negative there. So this negative goes in the front, this negative, that takes care of the derivative of cotangent x. These are things I would look for first, because these are things we've been doing for a very long time, and you don't want to overcomplicate an easy problem.
A way that I found helpful is
Mhm.
if you think of like tan x, the derivative of secant squared x, so everything has to like go all together. So you have
Yeah, so the derivative of tan x is secant squared x. So if we go cotan, that derivative is negative cosecant squared x.
Oh, that's not what I was talking
Oh,
about. I was saying like if you have a tan x and then you go to secant squared x and then they ask you to integrate secant x, and you can say, oh, like I need another secant x and then another tan x because.
okay, I see what you're saying. Yeah. That's okay. It's okay. All right, let's move on. Okay, then we learned, still in chapter 4, 4.5, we learned about use substitution. Okay, we're still doing use substitution. It's not an easy concept, but I will tell you, the ones we did at the beginning, what I'm hoping is that now you think those are easier than you did when we first learned them. Okay, that's the goal here, is that you get better at what you know, and then you keep chipping away at what you don't know. So the very first thing, and this was really our only thing we had for a while, is parentheses. Okay, let's let u equal the thing in parentheses.
Wait, how do we know that it's not just the normal?
Okay, so this is not a polynomial. This is not as simple as a number x to a power.
Oh, it's got
And I don't have product rule or quotient rule or anything like that for integrals. I only have that for derivatives. So I can't integrate this in my head. So this is how I know I have to have some other way to do it. Now, if you wanted to, you could do x squared plus 1 times x squared plus 1. Distribute all that out. Then distribute an x through it. And then it would look like example 1. You could do that. But if I made this squared into like a 7, then that would become like an impossible way to do this problem. So I'm going to go ahead and stick with this way. But that's how we know, because I can't do it any other way.
So, would you say that a general rule would be if there's an exponent outside of the parentheses, it's use substitution, but if there's not, it's just normal?
Yes, that's a good thing. Yeah. Okay, so what would du equal in this problem? 2x dx. What do we do with the 2? We move that thing out to the front. Okay, and what we're looking for here is that we let u be part of the problem. Then the other part of the problem should be right here. That's good. That's what we want to have happen. When that doesn't happen, we got to figure out what the deal is. But when it does happen, we're like, good, okay, now all I got to do is write my u, in this case squared, and then the x and the dx get swapped out for 1/2 du. And now this is something I can antiderive using the basic rule. So the antiderivative of u squared would be 1/3, whoops, sorry, I don't know why I wrote x, apologize. That's a u. The antiderivative of u squared using the basic power rule, add 1 to the power and all that. And then the only other thing we need to do, you don't have to simplify 1/2 and 1 cubed. I'm going to go ahead and do that. What you do have to do is go ahead and say, okay, what was u again? It was x squared plus 1. And I want to remind you that a lot of these problems you can easily check by deriving your answer, and you should get what you started with. Okay. So then, moving on to chapter 5, This was 5.2, by the way, when we did this, and this is just for reference if you want to know. Then we started looking at these types of problems. And what you do not want to do here is start with trying long division. That's like what we do when other things don't work. We want to try the things that we've done a whole lot of first, because that's more likely going to be how this problem works out. So in this case, if you let u equal the denominator, okay, so I let the whole denominator be the u, what I'm hoping happens is that the numerator is the du. So what is du in this case? 2x minus 1. Isn't that awesome? Uh-oh.
My bad.
Technical difficulties. Hopefully the recording is fine because my computer has a battery in it.
Again, sorry that happened.
It's okay. You did not intend to do that, so it is okay.
Sure.
I'm pretty sure.
Sorry, I guess I'm not.
Okay, I want you guys to try to finish that problem that we're on right now. Everybody try to finish that one. Sometimes it... So if you're watching this video, just hang in there for a second. It's gonna be okay. Y'all are gonna remember that forever.
It's never gonna be forever.
Okay, so on this problem right here, you should have had 1 over u du, which is natural log of absolute value of u, plus c, which is natural log of, what was our u again? It was this x squared minus x plus 2. So that's how you finish that problem. Let's go ahead and check that answer. This works out because the numerator is exactly what I needed in the du. Okay. So on this third one, we're going to let u be square root of x because that is the power of e. I'm going to write it as x to the 1/2. So then du would be 1/2 x to the negative 1/2. And then what happens to this 1/2 in front here? It becomes a 2. When I divide a half over, it becomes a 2. And again, what I'm hoping here is that all of this right here in the du statement takes care of the other part of the problem. If it doesn't, I will have to deal with that. If it does, great. I can move on with the problem. So in this case, it does. Okay, the x to the negative, that accounts for the denominator. The 1/2 accounts for the square root. So all I'm left with is e to the u. So what is the antiderivative of e to the u? E to the u. E is for easy. Does that mean all e problems are easy? It means that it's easy to antiderive and derive because it doesn't change. That only happens with e to the x or e to the u. So I'm going to go ahead and rewrite my final answer. Okay, how are we doing? Okay, so what happens when things don't match up? That's the bigger question, right? Once you're pretty sure you're doing these problems correctly, then some of this weird stuff comes along. By the way, this last one was 5.4, sorry. This Toco goes back to 4.5, by the way. I'm working these again, not in order that we learned them, but in order of things you need to check. You want to try to see, can you just do normal U substitution? And will it work out? Okay, so I'm already giving you a heads up that this isn't going to work out, but I'm going to play dumb for a minute and think, I didn't know that was written there. Okay, so any ideas on what we could let U equal? Why did you guys pick that? Yeah, we could write that as parentheses 1/2 power. Okay, so we let U equal the thing in parentheses. Then we're going to go ahead and do the du. What would that be? Negative dx. The negative gets moved over, which ultimately goes in front of the integral symbol. And unlike the other problems, the only thing that gets taken care of is the dx. This x, which I'll put in like a yellow box, that's extra. This is how you know this is a Toco problem. Okay, when you have that extra x. And it could be more complicated than x, but not much more. So when you have that extra x, like we have a u to the 1/2, but what goes in place of x? This is when you got to take that original u and say, okay, what should x equal? If I got x by itself, 1 minus u, you could totally call it negative u plus 1. They mean the same thing. So in place of that x, I'm going to write 1 minus u. And then this is also my u to the 1/2. And then the dx gets replaced with du. We know that sometimes this is all you have to do. This was multiple choice or something. Let's go ahead and finish this one out though, because this is kind of like our big review for integration. So before we integrate, what do we need to do here algebraically? I need to distribute. Okay, 1 times u to the 1/2, that's just u to the 1/2. Minus. What is u times u to the 1/2? How are you guys getting 3/2? You add the exponents. The exponent on the normal u is just u to the 1. 1 plus 1/2, that's 3/2. Now we're ready to integrate. Because I have that negative in front and that's supposed to apply to everything, you could distribute it if you wanted to. I'm not going to do that. You could. I'm going to put a bracket though, and this is going to symbolize that I'm ready to actually anti-derive. Don't worry about the fraction. It's not that big of a deal. You just got to be able to add 1 to it. So what's 1/2 plus 1? 3/2. And then that same number is what you put in the denominator. Minus 1 over. The next one would be 5/2, and that's what you put down here. If you want to simplify those into 2/3 and 2/5, you could. If you wanted to distribute the negative, you could. I'm not going to do either because it's not required. And we're already doing enough in this problem. Simplifying is just not something we're going to do. We do need to go ahead and put in 1 minus x in place of u. So that was not friendly. But I will tell you, the first day we did Toco, this would have been like a, oh my gosh, I can't believe this is even a thing. And today, a lot of you know how to do this. Those of you that don't know, you have an idea of at least what's going on. So we just got to move forward with wherever you're at. Okay, next page. Okay, so again, we're moving in order. All right, you do normal U substitute. You do try it without U substitution. Then we try our normal U substitution. If we have a Toco, we can recognize it. And then sometimes we get some problems like these. These don't necessarily mean they're more difficult, but I mean, some of them are going to be, but not all of them. So if you're looking at a problem like this, the first thing you are going to try is let u be what? The denominator. These are all fractions. They're all rationals. So what would happen in this first one if we let u equal the denominator? That wouldn't make sense. We don't let u equal x alone. It wouldn't make the problem any easier. What would happen in B if we let u equal the denominator? The numerator is way more complicated than our du, so that wouldn't work. Similar thing would happen here on C. If we let u equal the denominator, the numerator wouldn't really work out. So sometimes it's as easy as just saying, hey, that denominator is one thing. Let's just divide each item. So what's x cubed divided by x? X squared. What's 4x divided by x? Just 4. And then this last one I'm going to go ahead and write as 2 over x. And then you just got to do each piece. That's the antiderivative of each piece. If you want to go ahead and write it out as 3 different integrals, you can. I'm not going to do that on this one, but you could. What's the antiderivative of x squared? 1/3 x cubed. This is just going back to the number 1, the basic rule. What's the antiderivative of 4? 4x. Okay, for this next one, I'm going to kind of disregard the 2 for a moment. Okay, I'm going to write it down here, but I want you just to think, what's the antiderivative of 1 over x? We don't need u substitution for this. Natural log of x. And I'm going to stick an absolute value on there. On your quiz, number 8, which is like this. Some of you made that one a lot more complicated than it needed to be. Again, knowing what to do is generally harder than actually doing it. Okay, so that's that. Okay, so then we get to something like this. And I've already put long division up here, but how would you know it was long division? Because the degree of the numerator is bigger than the denominator, and normal u substitution did not work. Okay, so I'm going to go ahead and do long division down here. Yes?
On A, instead of putting 2 over x and then transforming that into 2ln, you do 2x to the -1.
It would still, if you change this to 2x to the -1, it would still be 2 natural log x when you antiderive. Because if you wrote that, the question is, what is this? If you try to antiderive, what would happen to your power if you try to use, it would go to 0, and that's your red flag that you missed a natural log.
Can you not just have that?
No. Okay, so I'm going to go through, I'm going to do this division thing pretty quick because I've already done this a few times. But you divide, you multiply. If you're still really struggling with this, you are going to have to do something to help yourself. You got to come into tutoring. You can get a friend to help you. You can watch some, there's lots of videos on YouTube on how to do this. I don't know. And then you bring down the 5. So divide, multiply, subtract, bring down. X goes into 3x 3 times. 3 goes into x. 3x plus 3. And then you would subtract. And that gives us a remainder of 2. So the way we write this is we go 2 over what you divided by. I think this type of problem would be a good one to go ahead and split up into actually 3 different integrals. So you could do x dx, you could do 3 dx, and I'm even going to bring the 2 out in front and make that a 1 over x plus 1. Because we can do that with numbers. We can move those numbers to the front. So a good test question for me to just test, do you understand this piece, is to have a multiple choice where this is the problem, and I say, which of the following are equivalent to the integral at the top? Okay? All right, anti-deriving x, that's just basic rule. Anti-deriving 3, basic rule. Okay, this last one, I'm not going to spend a lot of time here, but you would want to let u equal x plus 1, and then du would be dx, and what you're going to end up having is natural log of x plus 1 plus c. So I'm not explaining all the steps there, but I wanted to really get out that you just got to split it up into 3 integrals. Then do what you need to do with each piece. Okay. This one down here, why can I not use long division here?
Because the power is greater on both.
Yeah, you can't take something that's big and make it, you know, I can't put an x squared into an x. That doesn't make sense. And if you try to do regular u substitution, you're going to get stuck. This right here is kind of like your last ditch effort. Don't do this early on. Do this when you're like, I've tried everything, I can't get this, I'll try this now. So this is where you're going to split it up into 2 different integrals. Another way you know to do this is one of these looks like arctan, and one of these looks like letting u equal the denominator. Okay? If you're kind of like thinking, well, one strategy would work if there was only an x, and another strategy would work if there was only a number. That's an idea for why you need to split this up. And so I'm not going to work either of these out. I'm going to kind of do a dot, dot, dot and give you the answer. But this first one's going to be 1/2 natural log x squared plus 25. That's if you let u equal the denominator. And then the second one's going to be an arctan. 1/5 arctan x over 5 plus c. Okay, so it's easy to do dot, dot, dot for me. So you might want to make sure that you understand how that process works. That might be something you want to look at on your own time. I'm going to keep that up there, but I'm going to scroll down a little bit. Okay, I didn't really go over this inverse trig because I know I'm going to do this. Inverse trig is not the first thing you're going to want to look for. It's something you're going to want to look for after you've already tried normal u substitution. If you tried to let u equal the 16 minus 9x squared, you're going to get stuck. Same thing here. It's not going to work. So then you notice, hey, there's a square root, there's a minus, this looks kind of like arcsin. By the way, let's just move that 5 out to the front. We want this thing to look like the formula, which will be given to you on this test. Because this right here equals arcsin u over a plus c. So what you got to do here is figure out what's a, what's u, what's du, and then work the problem from there. So what is a? 4. What's u? 3x. Don't skip the du step. Even on these, you still have to do this. 3 dx. That 3 gets bumped over. So I now have a 5 and a 1/3 that need to go in front. I'm going to write that as 5/3. Arcsin u, which was 3x, over a, which is 4. These are not easy, but the fact that I'm giving you the formula, what that means is you've got to figure out when you need to use it, but actually using the formula should be easier because I'm giving it to you. You don't have to memorize it. Eventually you do, but not for this test. Okay, so what do we got going on here? Arctan. So I'm going to write that formula up here. There was no square root and there was a plus. And the other reason the formula was different, it was 1 over a arctan u over a. So you got to go through the steps. What's a, what's u, what's du? That's true for both things. So what is a? 5. What's u? This is the only time you get to just let u be just a single x. So there's no number I have to divide over. So we can just go straight into the formula. 1/5 arctan x over 5 plus c. This was the new thing we learned yesterday. this stuff is definitely compounding. So at this point, if you're like, I was good until this number and then I was bad all the way through, that makes sense. If you have gaps about the regular U substitution, this isn't going to make a whole lot of sense to you. I would like for you, before we still have another minute or two, for your own sake, I want you to go through these 5 and say, what do you totally get and what do you not get at all? And that's what you've got to focus on over the next 2 days. We have a test on Friday.